So yesterday we discussed about the topic the welded joints under eccentric load condition. So these are all the questions we discussed yesterday. So whatever the problems we practiced yesterday are case one type. So problems are related to the case one type. Yesterday we discussed this one. And today we are going to solve one more problem is in case one type. Let's see this one. So an arm is there A and it is welded to the hollow shaft at section 1. Here on this shaft we can find the two sections at 1 at 2 it is welded. It means an hollow shaft one arm is welded at one section and this hollow shaft is welded on the vertical plate at 2 section, and the hollow shaft is welded to section. The arrangement is shown in figure. The force P is applied here at a point A on the arm. The force how much? 15 into 10 to the power of 3. That is perpendicular to the axis of the arm. And calculate the size of the weld. So first write the given data. First diameter of the rod is given 80 mm and load is given 15 into 10 power 3 newtons. Permissible shear stress value is given maximum value 120 megapascal and asking to calculate size of the weld is how much. So here see such type of problems is comes under the first case. So why is first case? Here on the vertical plate the rod is welded perpendicular to the surface, and here at the section 1 also it is appearing as a cantilever beam. It means wait for wow, it is giving some trouble. Given at a diameter of the rod is 80 mm and the force is given 15 kilonewtons. Permissible shear stress given as 120 megapascal and asking to calculate size of the weld is how much. Now first identification of the problem is important here. So the given problem comes under which case? This is the problem. Here see the load is applying on the arm at a point A. This applied load is not passing to the axis of the shaft. So this is the under eccentric load condition. So again in eccentric loading condition, we have two cases, case 1 and case 2. Between these two, the given problem belongs to which category? So the shape is appearing, the diagram is appearing here, 90 degrees here, Here also 90 degrees. Means the welded portion, it is appearing in the manner like cantilever beam. This we discussed in the class, isn't it? So in the same manner here, this diagram also appearing. So this is a case one type problem. Now in this case one type of problem, what happening in case one type problems, simultaneously the component is subjected to two types of stresses. First one, what is the direct shear stress. Second one is the bending stress. So these two stresses are acting in first case type of problems. So because of this reason, what we are doing, we are selecting the theories of failure. That is first one, maximum principal stress theory. Principal stress theory, what is that? Maximum principal stress theory equation, bending stress by 2 plus 1 by 2 into square root of bending square plus 4 shear square. And second one is the maximum shear stress theory. So with this maximum shear stress equal 1 by 2 square root of sigma b square plus 4 shear square. So these two theories of failure we are considering because on a particular component simultaneously two different in nature stresses are acting. So again here the question is which equation we have to select. We have two equations here, maximum principal stress theory and another one is maximum shear stress theory. So between these two, which one we have to select? See the question properly here. The question is given permissible shear stress is in the weld 120 megapascal, means shear stress value is given. So that's the reason we have to select the second equation. So write the second equation here. According to shear stress theory, according to shear stress theory, maximum shear stress equal 1 by 2 square root of bending square plus 4 shear square. Now this maximum value is given in the question as a 120. Now we don't know sigma b value and we don't know the shear stress value. Okay. So to know the shear stress value, first one, this is known as primary or direct shear. This one is known as primary or direct shear stress. So this equation is load by area. So how much load is given in the question? The load is given in the question 15 into 10 to the power of 3. 15 into 10 power 3. Now what is the area here? Failure area we need to consider. So see here, because of application of this one is going to subject you to primary shear at 1 section. Okay. So at 1 section, the failure area, this hashed lines area we need to take, means at this particular section the welding is applying here. So at this section, what is the failure area? So for this, already we derived this such kind of derivation like that. I'm showing see here. This is the rod and this is the vertical plate. Okay. So to this we are doing the welding in this manner. So when it is subjected to the torsion, shear, what is the equation that we already derived in the beginning of the welding topic? What is that? Maximum shear stress equal What is that? 2.83. 2.83 into T by pi into S into T square. This one we already derived at the beginning of the welding topic, where T is the torque. How much torque force into perpendicular distance. So here we are, why I'm selecting this equation here, I'm getting difficulty to select the area. So that's the reason directly I'm taking the equation, this one. Okay. So T, I'm now calculating T 15 into 10 to the power of 3. Now perpendicular distance, how much? The perpendicular distance we have to take. Now perpendicular distance is, this is the force applying, and perpendicular distance is 240 from the axis of the shaft. So that is into 240. Now T, tell me the how much T value, and D is the diameter of the shaft that is given in the question as 80 mm. 80. Now tell me the T value, torque, how much generating on the shaft. How much T value, Bob? Ilyas Baba, are you there? 316. What is T value? Rule number 16. This is not there. Rule number 56. Harshita, are you there? She is also not there. 318.
Yes, sir.
What is the T value? Are you calculating or just doing anything other?
Targeting, sir. Calci is not available. Doing in phone, sir.
Do it fast. I am asking the questions. People are living in class. How much T value? 3600 into 10 to the power of 3 Newton mm. Now substitute the T value in the stress equation. Shear stress equal 2.83 into 3600 into 10 to the power of 3, 10 to the power of 3, by pi into S value we don't know, that is asking in the question how much the size of the weld, and the D value is given in the question, diameter of the rod as 80. Now tell me the shear stress value. The value will come in terms of S megapascal. Now tell me the value of sigma S, not T value. Do it first. Very good, Harshita. Answer given 3.6 into 10 to the power of 3. Okay. Now tell me the shear stress value. Now the shear stress is 506.6 by S megapascal. The primary shear stress we calculated. Now second one is here bending stress. Bending stress. To calculate bending stress, the basic equation is M by Z. Now what is the Z value here? So Z value we have to take from the table. So see this one. The Z value we have to take from the table. So this is the Z value for the circular rod. This is the one. Okay. Now see here. If we write the Z value here, whatever we selected from the table, pi d pi t into d square by 4. Pi into t into d square by 4. M means load into eccentricity. So this type of problem we already solved in the previous case. That is, when the shaft of circular shaft welded to the vertical plate in this manner and subjecting to bending moment. For this type of situation, the bending stress we calculated already in the previous case. What is that? 5.66 into m by pi s d square. Okay. So if we derive this one, we will get this equation. What is m? M is a bending moment load into eccentricity. Okay. Now this bending stress is going to generated at the section 2. The shear stress is going to generated at the first section. Now bending is going to generated at the section 2 here. Okay. So at the section, the load is given here 15 into 10 to the power of 3 and distance is 200. So E value, I'm calculating separately M value P into E. So P value how much? 15 into 10 to the power of 3 and E value how much? E value is 200 minus 50 by 2, means from its center, from here to here. So it means from 200, if you subtract the 50 by 2, it means 25. If you subtract the 25, we will get the distance from here to here. That shows the perpendicular distance. Now M value how much we got? Tell me the M value P into E. 26.
Sir, 2625 into 10 to the power of 3.
Very good. What is the units? Newton mm. Now substitute the m value here. D value already given in the question. Diameter of the rod 80 mm. Now answer will come in terms of S 5.66 into 2625 into 10 to the power of 3 by pi into S into 80 square. Now what is sigma B? Tell me the sigma B value. 738.895.
738.95, sir.
Okay, by S megapascal. Now see here what parameter we calculated, sigma B and sigma S value calculated. Why we calculated? Because according to shear stress theory, this equation we selected, in this equation to get the S value we require the sigma B parameter and sigma S parameter. So sigma B just now we calculated and sigma S 506.6 right here, 120 equal 120 megapascal equal 1 by 2 into square root of sigma B value 738.95 by S square plus 4 into 506.6 by S square. Simplify the equation and now tell me the S value how much. S value is in mm. Do it first. Tell me the S value. S value is 5.22 mm. Okay. So with this, the case 1 type of problems over. Now we are discussing about the case 2 type problem. So case 2, how to identify the case 2? See here, the identification is important here. For the one plate, this is a one number one plate and this is second plate. These two plates are making a joint with the help of welding, overlapping each other. Okay. So overlapping the two plates and joining the these two plates with the help of welded joints. Now applying the load with some eccentricity value 125 mm. Okay. Now asking to calculate what is, find the size of the weld. Here also S value how much. So first given data, write the given data. Load is given as 15 into 10 to the power of 3 and eccentricity is given as 125 and shear stress is given as 80 megapascal. Okay, and the length of the weld is given as 50 mm. So this is a 50 mm length of the weld is given as 50 mm. Now asking to calculate the size of the weld how much. So see here This is the case 2 type problem, case 2 type of problem. So when the component is subjected to case 2, so it means here there is two types of stresses. These two types of stresses are in a same nature. What are those? First one is a primary shear stress. Second one is a secondary shear stress. Shear stress. So primary shear stress is due to the self weight. Secondary shear stress due to the turning movement generated by because of the applied load. So first one I'm calculating the shear stress. The primary shear stress is vertically acting downward here. So if you consider one point here, the primary shear stress is always acts vertically downwards. That is I'm giving as a shear stress 1. This is a shear stress 2. Okay, vertically acting downwards direction. How much the intensity? This intensity is shear stress is equal load by area. Load is 15 into 10 to the power of 3. Area failure area we need to consider, because here this is the two parallel fillet. So two failure areas are going to generate 2 into T into L. So T means what here? 0.707 into S. T is the throat thickness. So the throat thickness will comes in under the size of the weld. In terms of size of weld, so substitute 15 into 10 to the power of 3 by 2 into 0.707 s into length of the weld is given in the question as a 50 mm. This is the primary shear stress. Now tell me the how much primary shear stress?
212.16.
212.16 by S, because here we don't know the S value, keeping as it is megapascal. Okay. Now second one, secondary shear stress. Secondary shear stress is generating. Now I'm drawing the second shear stress. Like this it is going to act. How, in which direction it is acting? So here this is the center of gravity for the given section. Now the applied load is, the load is applying in a clockwise direction. So the reason sigma shear secondary shear stress also going to generate in a clockwise direction, that is perpendicular to the radial distance from the center to this point. This radial distance is known as R2. Okay. So what is secondary shear stress here? Secondary shear stress is directly proportional to the this radial distance. Now this one already we derived. What is that? Shear stress equal secondary shear stress equal T into E, T into E into R2 by J. What is J here? J is a polar momentum of inertia. This J value we need to take from the table. So what is that? This one we already calculated in derivation. J value for this type of figure. For this type of figure, J value we already calculated. How much? So I'm writing here. T value, force into perpendicular distance, that is 15 into 10 to the power of 3 into eccentricity 120 into R2. R2 how much here? Refer the figure. R2 we don't know. So to get the R2 value, complete this one rectangle. From here to here, it is 40, because this total width of the plate is 80. So if we take the half portion, that is a 40. Now from center of gravity to this primary shear stress distance is, if it is total 50, it is 25. Now this opposite sides are known. We don't know the this length. So to get the R2 length, we know the Pythagoras theory, that is 40 square plus 25 square. Now R2 how much? 47 mm. Okay. So R2 calculated. by J polar moment of inertia we already calculated 127 850 into S. So actually this J value we have to take from this table, Babu. It means you have to remember the entire table. So here the given question belongs to third diagram because at the top this type of weld is done and at the bottom also this type of welding is done. So for this the respective polar moment of inertia is we need to take this one, okay, where T is nothing but 0.707 into S. B value is the width, this distance, that is in the question given it as a 80 mm, and L is the length of the weld, this one that's also given in the question, and here also length of the weld. Submit the all values here in this equation, you will get the this answer. You will get the 127 850 into S. Now what is S that we have to calculate? Now tell me the secondary shear stress value. 150 into 120 by into 47 by 127 850 into S. 689.3 by S megapascal. Sigma 1 and sigma 2 both we calculated. Now see here for this point two stresses are generating. Okay, very good, Babu. Two stresses are generating. So because of these two stresses, one resultant stress is going to generated. So this is appearing like a parallelogram theorem. Okay. So what is the equation for resultant stress value? The resultant stress value equation is square root of 1 square plus 2 square plus 2 into 1 into 2 into cos theta. So what is cos theta? Cos theta is R1 by R2. R1 value how much? The distance from the this one here to here, the distance is known as R1. This one is R2. So R1 how much? R1 is a 25. R1 is 25. R2 how much? Just now we got the R2 value. R2 value how much? Here to here 47. 47. Now what is the cos theta? Cos theta is 0.532. So substitute the all values here in this equation. Sigma 1 is 212 by S whole square plus whole square plus 2 into. Now tell me the result resultant stress value. Make it fast, Babu. What is resultant stress value? How much? Resultant stress value how much? 795.13. Very good. 795.13 by yes. Now resultant stress value is given in the question, that is 80 megapascal. So in place of resultant stress, write 80 megapascal. Now substitute the 80 here and tell me the S value. The S value is in millimeters. 9.93. Very good. It means nearly equal to 10. Size of the weld 10 mm we have to maintain. So this is the second case type of problem. This welded joints under eccentric load condition is very important for external point of view. Long answer question, Babu. You do perfect practice with the case 1 and case 2. Maybe case 1 asks for the 7 marks, case 2 asks for the 7 marks, total 14 marks. Okay, don't take it easy for welded joints under eccentric loading condition. Now this is the second type in the eccentric loading condition under case 2. So see this figure I'm showing in the table, same figure. Now tell me which cross-sectional figure we have to select from the table. I'm displaying the screen on the screen. Tell me the figure name. Which figure should I consider for the given problem? So see, this is the question. This is the question. Now my question is, which figure should I consider? Figure number. Tell me the figure number. 6 or 7 or 8 or 9.
7.
Very good. Seventh figure we need to consider because see the welded section figure here. It is appearing in a C. So the question is also here C. Now if you observe the figure, the C section is having the center of gravity here. Now from the center of gravity to the innermost layer, this distance is given as a x. How much x value here? L square by 2l plus b, where L is the length of the weld. Okay. Now for this type of problem, the section modulus is given here. So not section modulus, polar momentum of inertia, this one. Okay. So I'm writing here. CG is going to lie here for this figure. Now from here to here, the distance is known as x. This x value is given in the question, not question in the table. This equation you have to remember, Babu. L square by 2l plus b. Okay. Now what is L? L is the length of the weld, 50 square by 2 into 50 plus b. B is nothing but width of the weld. How much width of the weld? The width of the weld is equal to the width of the plate. That is 100 mm. Now tell me the x value how much? Tell me the x value. 12.5. Very good. Who is giving the answers? Rule number 13. 12.5. Okay. Now, what I said, this type of problems subject to two types of stresses. What are those? Direct shear stress or primary shear stress, and second one is secondary shear stress. So when it is subjected to the direct shear stress, the first one, direct shear stress, sigma 1. What is the equation? The equation is load by area. Load is given 60 into 10 to the power of 3. Area is failure area we need to consider. That is 2 into T into L. So that is 60 into 10 to the power of 3. by 2 into 0.707 into S into L, length of the weld is given 50. Okay. Now tell me the sigma 1 value how much in terms of S. Right? Don't forget to write the units, Babu. For writing the units also you have the marks. What is the sigma 1? Primary shear stress. 848. Very good. So you recheck again, not it's not 848. Where you are doing mistake. 16 to 10 to the power of 3. Okay. Here I did one mistake here. What is the area here? Failure area, not this the one. I'm writing here again. Failure area, I'm separately writing here. 2 into T into L for this one. This is the one. This is the one. So same diagrams is appearing. So that reason 2 into T into L I'm writing. Now from here to here, another weld is there. For this type of weld, we have to add plus how much L into T into, sorry, L into T. So what is L into T? L into T into B. Not L. So this is the B and this is the throat thickness T. So B into T. So T means 0.707. I'm writing here 2 into 0.707 into S into L plus T value 0.707 into S into B value 100. So this is the area for the this welded portion because see it is appearing in a C channel. So if we draw one line here, it will complete make a one rectangle. If I draw one line here, it will complete one rectangle. So two rectangles similar type. So that is 2 into S in 2 into T into L. Okay. And for this figure, from here to here, the area is B into throat thickness. That is T into B. T value is 0.707 into S and B value is 100. Now what is the answer for primary shear stress? 424. 424.32 megapascal. Very good. In terms of S. Now secondary shear stress we have to calculate. So to calculate secondary shear stress, the equation is P into E into R2 by section polar moment of inertia. So polar momentum of inertia, from the table we have to write this J value. What is the J value from the table? I'm writing the from the table value. J equal T into B plus 2L whole square by 2L minus L square into B plus L whole square by B plus 2L. Where T is a throat thickness, that is 0.707 into S. Now calculate the J value in terms of S. and substitute here. P is nothing but, I'm writing again here, P is a 16 to 10 to the power of 3. Eccentricity is given 150. See, eccentricity means distance from the load applied to centroid. This is the E value. So to get E value, see here 150, from here to here 150, and here to here 50. 150 plus 50 minus, from here to here we have to subtract. How much this distance? This distance is known as X. How much we got X value? 12.5. 12.5. So how much this one? 200 minus 200 minus 12.5. How much? 187.5. This is the eccentricity value. Uh, 187. R2 value how much? So suppose consider this is the one point and this is the primary shear stress vertically acting downward, and this is a secondary shear stress rotating clockwise around the center of gravity. Okay. Now from here to here the distance is 50. Now here to here how much? 50 minus 12.5. From here to here, from center of gravity to this distance how much? This distance is 50 minus x, that is 50 minus 12.5. How much the this distance? How much, Babu? 50 minus 12.5. 37.5. This 37.5 represents the length of this one. Now see this figure. This is the R2, we don't know. This length is known as 50. This length is 47.37.5. Now what is R2? As per Pythagoras theory, R2 equals square root of 37.3, so 37.5 square plus 50 square. Now what is R2? Tell me the R2 value. $62.5. Very good. 62.5 megapascal. No, mm. So R2 we calculated. So substitute R2 value here, 62.5. The J value, how much you got? J value. Tell me the J value. Do it fast, Babu. J value, how much? How much J value? Babu? You are not telling the answers. J value is 275 into 10 to the power of 3 into S mm power 4. Substitute here 275 into 10 to the power of 3. Now calculate the sigma 2 value, shear stress 2 value 2557. After simplifying this one, 2557 S megapascal. Primary stress we calculated and secondary stress also we calculated. Only the thing is we need to substitute the values. So according to the uh, parallelogram theorem, resultant shear stress equal square root of 1 square plus 2 square plus 2 into 1 into 2 into cos theta. Cos theta equal R1 by R2. R1 how much we got? R1 value 37.5. R2 value how much we got? 62.5. Now with this cos theta how much? 0.6 degrees. Now resultant stress value is given in the question 140 megapascal. 140 equal square root of sigma 1 value how much we got? 424 by S square plus 4 into 1 by 2 plus 4 into sigma secondary shear stress how much we got? 2557 by S whole square plus 2 into uh, 424 2557 by S into cos theta 0.6. Now tell me the S value in mm. Tell me the S value.